Assalamu alaikum and welcome everyone to this tutorial. In this tutorial, I'll be giving you a walkthrough of Cambridge IGCSE ATP Physics paper of February-March 2025. Remember, this paper is related to the extended syllabus of the IGCSE. So let's start with the question number one. Question number one says, a student investigates the behavior of a spring and then uses the spring to determine the mass of an object. So this is the primary objective. We have to determine the mass of an object using this setup. The apparatus is shown in figure 1.1. So there is a spring which is clamped to a support, and there is a mass hanger where the mass could be placed. The student suspends a mass m is equal to 100 grams from the spring. She measures and records in table 1.1 the stretched length L of the spring as indicated in the figure. Describe two techniques for measuring the length of the spring to ensure an accurate reading. You may draw a diagram which may support the explanation of the answer. So let me explain how to do it with the help of this diagram. I have considered the same spring which was given in the question. What we will be doing is that we will be clamping a scale like this, and you can see the stand over here. The scale is clamped. Then we are going to use two set squares. This is going to be the set square 1, and let me call it set square 2. So this is our first set square, and this is the second set square. The purpose of using this first set square is to make sure that the scale is perfectly vertical and making an angle of 90 degrees with the surface on which it is placed, so that we can read the scale properly and get an accurate reading. Then there is a second set square which will be used over here in order to make sure that the reading that we are getting is as accurate as possible. So this is how we are going to do it. And now I'm writing a 2-mark answer for it. So the first thing that I'm writing over here is, so I'm writing clamp meter rule besides spring and use set square 1 to ensure that it is at right angles to the surface where it is placed. Secondly, we will use another set square. So use set square 2 as a guide to read the meter rule. So that we can get an accurate reading. And besides this, we have to make sure the eye level of the reader or the experimenter is perpendicular to the scale of the meter rule. So these are the two main points that we can write in this answer for a 2-mark answer. I've also drawn a diagram here in order to help explain how this process is going to be done. Okay, the next part says she repeats step A for values of m is equal to 200 grams, 300, 400, and 500 grams. Her readings are shown in the table. In the table, we can see that we are given with the values of mass in grams and length in centimeters. Okay, plot a graph of length in centimeters on the y-axis against m in grams on the x-axis. Start the axis from origin 0, 0. Draw a best fit line, a straight line. The line might not go through the origin. So it's not necessary that the line would be passing through the origin. Okay, so for this part, we are going to get 4 marks. The first thing where the first mark would be assigned is to label the axis. So on the y-axis, I'm writing length in centimeters as given in the question. And on the x-axis, I'm writing mass in grams. Now, the second thing after labeling the axis is to number the axis. Now, for numbering, remember that for the numbering, I'm writing over here just to explain it. We will be using the intervals of 1 or 2 or 5, which means that if our value is required, we would start with 0, 1, 2, 3, 4, 5, and 6. This is what we can do. Or in some other case, what we can do is we could go for a difference of 2, like this. And in some other case, we might go for 5, 10, 15, and so on. Similarly, this could also be done in the decimal points, like we could also go like this, 0.10, 0.15. So this is a normal standard way of numbering the axis when we are plotting the graph. Remember, it should be a multiple of 1, 2, or 5. Okay, now, according to the given values, the mass is from 100 to 500. So it would be convenient to just go for a scale of 100. So I'm writing 100, 200, 300, 400, 500, and finally 600. Okay. Now the values of length, they start from 6 and they go all the way to 21. So I'm going to go with the scale of 5 over here, 5, 10, 15, 20, 25, and finally 30. Now I'm going to mark the points over here. The first point is 6 and 100. Now I've plotted all the points. On the x-axis, it is simple that each small box is representing a mass of 10 grams over here. And on the y-axis, each small box is representing 0.5 0.5 centimeters of length over here. So the next step is to make a line of best fit over here. This is how my line of best fit is being drawn over here. The line of best fit. Okay. So now they are saying use your graph to determine the length L naught of the spring with no load on it. So without any load, the graph is, touching the y-axis when no mass is attached to the spring at 2.5 centimeters. So I'm writing 2.5 centimeters. Okay. In the next part, it says an object X is suspended from the spring. On figure 1.2, measure the stretch length Lx of the spring. Now, for measuring this length, we will again be using the scale, and it should be perfectly vertical. And now we are going to see how much length are we getting for this part. So the length that we will be getting is about 10 centimeters. So I'm writing 10.0 centimeters. Remember, for the scale, the least count is 1 millimeters or 0.1 centimeters. This is the least count. So whenever we are writing a value measured with the scale or the ruler, we have to write a 0.0 if the reading is in centimeters. Okay, use the graph and your reading in the previous part to determine the mass mx of object x. Show clearly on graph how you obtained your answer. This instruction is very important. Whenever we are going to read a value from the graph, we have to draw the dotted lines on the graph, whether they ask us or not, in order to get a better answer. So I'm going to make 2 lines over here. Okay, so here I'm getting an answer of 210 grams for the length of 10 centimeters. So I'm going to write the answer over here, 210 grams. And we are getting 2 marks for it if we are showing on the graph how we got this value by drawing the dotted lines on the graph. Okay, the next part says 2 students measure the mass of another object using the same method and apparatus. One student records the mass as 132.6 grams. The other student records the mass as 130 grams. State and explain which answer has the more suitable number of significant figures for this experiment. So for this experiment, uh, as we have seen in our graph, the smallest value that we are able to read from this graph is 10 grams, and less than 10 grams is not readable over here. So the one who has recorded the value of 132.6 grams, the number of significant figures are not suitable for this experiment because of the data represented in the graph. The other student who has recorded the mass as 130 grams, yes, that will suit those number of significant figures are going to suit this experiment. So I'm writing the student with the reading of 130 grams. And what's the reason behind it? Because it is suitable, because the smallest reading on the graph is 10 grams. So less than 10 grams is not suitable for this experiment. Let's move on to question number 2. It says a student investigates the effect of insulation on the cooling of water. So what we can see in the figure is a beaker, and then there is a beaker A with the insulation around it. And we have a bench over which a thermometer is clamped over here, and we can see the reading on the thermometer. It is magnified over here. He uses the apparatus shown in figure 2.1. Beaker A is covered with material that is thermal insulator. Beaker B is identical to beaker A but has no insulation. Okay. Record room temperature theta R shown on the thermometer in the figure. Now, the reading on the thermometer is 1 unit above the 20 degrees centigrade. And we can see that the least count of this thermometer is 1 degree centigrade, because from 20 to 30, there are 10 divisions. So it means the thermometer here is showing a reading of 21 degree centigrade. Okay, moving on to the next one. It says describe one technique used to ensure that the room temperature reading is as accurate as possible. So for getting an accurate reading, what we are going to do is we are going to wait till the liquid in thermometer stops rising. If we take the reading while it is still rising, the reading is not going to be accurate. Before taking the reading, so once it has stopped and it has stabilized, then we are going to go and record the reading of the thermometer for the room temperature. Okay, the next part says the student pours 200 centimeters cube of hot water into beaker A and records the temperature theta at time is equal to 0. He records in table 2.1 the temperature of the water in the beaker every 30 seconds. The student repeats the procedure for beaker B. It is important that the temperatures are recorded at exactly every 30 seconds. Describe a technique which will make it easier for the student to do that he or she is able to record the temperature at every 30 seconds. So for that, we would write leave the thermometer in the liquid permanently. We are not going to take out the thermometer and then insert it again during the experiment. And student will take the reading at every 30 seconds interval. So this is how we can make sure that the readings are taken every 30 seconds. Now, write a conclusion stating whether the insulation affects the rate of cooling of water. Justify your answer by referring to values from the results. Now, beaker A is with insulation. It started with a temperature of 92.5 degrees centigrade and it ended up with a temperature of 85.5. So 92.5 minus 82.5 gives us a temperature difference of 7 degrees centigrade. In beaker B, without insulation, we are starting with 93 and we are ending up with 83. So there is a difference of 10 degrees centigrade over here. So their difference is going to be equal to 3 degree centigrades over here. Now we have to write the conclusion where the insulation is affecting the rate of cooling or not, and then we have to justify whatever answer we are writing by using the values over here. So I'm writing the total temperature drop for beaker A is 7 degrees centigrade, while for beaker B, it is 10 degrees centigrade. Since the experiment is conducted for a short period of time, which is 180 seconds, and it will be equal to 3 minutes. The difference of temperature drops is 3 degrees centigrade, which is quite significant. Hence, we can say that the insulation affects the rate of cooling of water. So in this very short period of time, still there is a difference of 3 degrees centigrade, which is a remarkable difference. So the rate of cooling is affected by the insulation used. Next part, calculate the average cooling rate X1 during the first half of the experiment for the water in beaker B. Use the readings for beaker B from table 2.1 and the equation theta 0 minus theta 90 divided by T. T is 90 seconds. Theta 0 and theta 90 are the temperatures of the water in beaker B at times T is equal to 0 and 90 seconds. And also they are saying that we have to include the units. So we have to write the units with the answer too. Now for beaker B, it is 93 at 0 and 87 at 90 seconds. So I'm going to use these two values. I'm writing X1 is equal to theta 0 is 93.0 degrees centigrade minus 87.0 degrees centigrade divided by the time of 90. Okay, so the answer that we are getting is 0.0667 degrees centigrade per second. So the answer here we are getting is 0.0667. Since all the numbers in the raw data were written to 3 significant figures, so I've also written the final answer to be in 3 significant figures here. We have to follow the convention used in the raw data. So the answer is 0.0667 degrees centigrade. Now it says calculate the average cooling rate X2 during the second half of the experiment for the water in beaker B. Use the readings for beaker B from the table and this equation, and theta 90 is the temperature is 90 and theta 180 is the temperature at 180 seconds. We again have to include the units. Now theta 90 is again 87 and theta 180 over here is 83 degrees centigrade. So let's use these values. I'm writing X2 is equal to 87.0 degrees centigrade minus 83.0 degrees centigrades divided by 90 seconds. The answer we are getting is 0.0444 degrees centigrade per second. So this is the rate of cooling here with the correct unit of degree centigrade per second. A student suggests that for this type of experiment, the temperature of the water in each beaker at T is equal to 0 must be the same for the comparison to be fair. Use your answers from the previous two parts, which are 0.0667 and 0.0444, to explain whether this is necessary. Now, the starting temperature has a significant effect on the rate of cooling, as we know. So when the difference between the surrounding and the starting temperature of the liquid or water is large, the rate of cooling is normally large. And when the difference is lower, the rate of cooling also gets lower. So we have to use these values and we have to state an answer over here. So first of all, I'm going to find the difference in the rates of cooling. And for that, I'm going to subtract the lower one from the larger one and see what we are getting. So it is 0.0223 degrees centigrade per second. Now, if I find the percentage difference between the two values, I'm going to write 0.0223 divided by 0.0667 multiplied by 100. This is going to be approximately 33%, which is much larger than the 10% limit of experimental accuracy. So there is a difference which is larger than the limit of experimental accuracy. So these two, the rates of cooling are, they cannot be considered as the same rate of cooling. So I'm writing an answer over here. The percentage difference in X1 and X2 is about 33%, which is beyond the limit of experimental accuracy. So they cannot be considered to be the same. Hence, it is important to start the experiment with the same initial temperature. So this is how we are going to write an answer to this 2-mark question after performing the calculation and checking the difference and their percentage difference. The next part says a student wants to eliminate from the comparison any thermal energy lost from the surface of the water. The two beakers being used for the experiment did not have any lid to cover here from the surface, so the heat was being lost from the surface of the beakers. Suggest a change to the equipment which will do that. So it's simple. We just have to place or cover the beakers with lid. Okay, suggest what effect this change will have on the cooling rates of water in beaker A and beaker B. So what the lid is going to do, it is going to reduce the heat lost to surroundings. Hence, cooling rates in both will decrease. Now, lesser heat is able to escape from the beakers, so that is why the cooling rate is going to be affected in a way that the rate of cooling would decrease in both of the cases. Okay, let's move on to question number 3 now. It says the student investigates the refraction of light by a transparent block. The student's ray trace sheet is shown full size in figure 3.1. The student places a transparent block ABCD near the center of the trace ray sheet of the ray trace sheet as indicated in the figure. Draw a normal to point N extended above AB. Label the upper end of the normal with the letter L. So we have to draw a normal at AB at point N. We will be using a ruler over here. And normals are usually drawn in dotted lines with the dotted lines. So here is our normal, and I'm going to label it as and now I'm going to label it as L over here. So this was the first part for 1 mark. The student draws line EN as shown in figure 3.1. On figure 3.1, measure the acute angle theta between the lines LN and EN. An acute angle is an angle of less than 90 degrees. So there is the line ln that we have just drawn, and there is another line en. Now these two lines are making two angles with each other. One is this one, and the other one could be this one. Now this outer angle is not acute. It's greater than 90 degrees. So we are going to find this angle. For this, we are going to use a protractor. So this is 90 degrees. And when I align with this one, this aligns perfectly when the angle is 50 degrees. So it means that my angle here is going to be 90 minus 50, which is 14 degrees. So for this theta, I am going to write 40. The student places two pins P1 and P2 on the line EN. As shown in the figure, measure the distance D between P1 and P2. Since this is a full scale diagram, so we have to carefully place the ruler over here with this line, and we have to measure the distance between these two. So it's coming out to be 4.0 centimeters. State whether the two pins are a suitable distance apart for accurate ray tracing. Explain your answer. No, they are not. We know that for the ray tracing diagrams, the minimum distance should be 5 centimeters between the two pins. So they should be at least 5.0 centimeters apart due to thickness of the bases of the pins, because there is a thickness of the base of the pin involved. So the distance should be larger to get an accurate value for this experiment. Okay, so this was a 1 mark answer. The student views images of P1 and P2 through the block. He places two pins P3 and P4 so that P3 and P4 and the images of P1 and P2 all appear exactly one behind the other. Draw a line through P3 and P4 and extend this line to meet CD. Label the point at which this line meets CD with the letter capital F. Label the lower end of the line with the letter G. Okay. So now we are going to again use the ruler and align these 2 points carefully. And now we will be making a line connecting these 2 points. So this is how the line should be drawn. Now the upper end of the line is to be labeled with F. So it is F over here. And this lower end of the line is to be labeled as G. Right. The next thing, extend line EN to approximately 5 centimeter below the line CD. Okay, so there was a line EN that was the line above there. And we have to extend this line below CD about 5 centimeters. So this is how the line would be drawn over here, and the length below CD should be 5 centimeters as given in the exam paper. So I have changed the color of this line as well. And it says label the point at which this line crosses CD with the letter H. Label the lower end of the line with J. So I'm going to write H over here and J. Okay. The next instruction, measure the acute angle alpha between the line CD and GF. Okay, so here is the line CD. Here is the line GF. So there are two angles. One is this one, which they have called alpha because it is an acute angle. The other one could be this one, and it is not an acute angle. So we are going to measure this angle with a protractor. Okay. So this is 0. And when we align it with this line, this comes out to be 53 degrees centigrade. So this angle alpha is 53 degrees centigrade. I'm going to write an answer over here, 53. Measure the acute angle beta between the lines CD and JH. In the same way, we have to measure this angle as well. So from 0, this angle is aligned at 50 degrees centigrade. Yeah. So this angle is named as beta between the line CD and HJ, and its value is 50 degrees over here. Okay. A student suggests that angle alpha should be equal to angle beta. State whether your results support this suggestion. Justify your answer by reference to values from the results. Okay. So in order to check that whether the two values are same or not, we have to go through the same procedure. We have to find their difference. So the first value is 53 and the other one is 50. So the difference is going to be 50 minus 53 minus 50 divided by the starting value of 100. So we are getting 3 divided by 53 multiplied by 100, and it is equal to, so it's approximately 5.7%, which is less than 10%. So when the two values have a percentage difference of less than 10%, experimentally within the limit of experimental accuracy, they could be considered as the same values. So I'm going to write an answer for this. So I'm writing yes, percentage difference between alpha and beta is 5.7%, which is well within the limit of experimental accuracy of 10%. So they could be considered as the same values. Describe two techniques to use in this type of experiment to ensure results are accurate. So the first thing is, since these are experiments related to light, so the first thing which is always advised in this experiment is conduct experiment in a dark room. The light should have a lesser intensity for conducting these experiments. Number two, make sure the base of pins used are sharp. So they can be easily, put in the paper and the cardboard, and the thickness should be lesser so that the experiment is not affected by the thickness of the base. Suggest one reason why different students all doing this experiment carefully. Means they are taking the values without parallax error and all errors like this. So they are performing it carefully, may not obtain identical results. So one of the reason is different thickness of lines could be made by different students performing the experiment. So when the thickness of lines are different, so it is going to affect the values measured in this experiment. That is why the students may have different results performing this experiment. Okay, the last question, the planning question number 4. It says a student investigates the resistance of a wire. Plan an experiment which enables him to investigate. Now, this is the objective, how the length of a wire affects the resistance of the wire. So basically what we are going to do, we are going to change the length. We are going to vary the length. So the parameter that we change or we vary becomes the independent variable or the quantity for the experiment. And the changing of length is going to affect the resistance. So the value of resistance is dependent upon the length of the wire being used. So this is the first thing. The objective should be clearly understood. And before writing anything, this should be understood that what is the independent or the dependent variable for this planning question. Resistance R is calculated from the equation R is equal to V upon I. Now this equation is telling us that there are two important quantities, voltage and current, that should be measured in order to find the resistance, where V is the potential difference, PD, across the wire, and I is the current in the wire. The apparatus available includes a selection of wires. So they would be having, different lengths, so that we can change the lengths and observe the effect of changing the length on the resistance. A variable power supply, an ammeter, a voltmeter. So ammeter would be used to measure the current I, and voltmeter would be used to measure the voltage V. And then we will be using this equation V upon I to measure and find out the resistance. So the first thing is, in your plan, list any additional apparatus needed to perform this experiment. So obviously, for resistance, we do have a voltmeter, we do have an ammeter, but for measuring the lengths, we do not have any apparatus listed over here. So the first thing I'm going to write down in the answer is the additional apparatus. So the apparatus needed must include a meter rule, for measuring the length of the wire. And secondly, they are saying complete figure to show a voltmeter connected to measure the potential difference across the wire. So we can see that there is a variable power supply, then there is an ammeter, then there is a wire. So the voltmeter must be connected across the wire in parallel, so that we can measure the voltage or the potential difference across the wire. So this is how the voltmeter should be connected. Also label it by writing down the voltmeter beside this symbol. Okay, the next instruction is explain briefly how to do the experiment, including the measurements to take so that the resistance can be determined. So this part requires us to write down the method of the experiment. So I've given a heading over here, method, and now I'm going to write in different steps. You can also write the answer in the paragraph form. Okay, first thing is set up the apparatus as shown in the figure. So after we have set up the apparatus, the first thing is we have to use a particular length of wire, and that length of wire is to be measured. So measure the length of wire connected in the circuit with by using a meter rule. So the independent variable is measured like this. Then set a particular voltage on the power supply. So we are not going to change this value of voltage used in the experiment from the power supply. We are going to keep it constant. The next thing is switch on the circuit. Number 5, record the reading on voltmeter, which will be labeled as V, and ammeter, and this reading will be labeled as I. The next step, resistance, which is our dependent variable. R can be calculated by using R is equal to V upon I. And finally, repeat the experiment with different lengths of wire. Okay. So the value of power supply would be kept constant. We are just going to change the length of wire used in the circuit, and then we are going to see how the voltage reading and the current reading is changed, and then we will be using those values to calculate the resistance. Okay, the next instruction is state the key variables to keep constant. These are called controlled variables. So I'm giving a heading of controlled variables. So the first thing could be material of the wire. Like if one wire is of copper, then the rest of the wire should also be of copper so that their resistivity doesn't change. Number two, all the wires should be at the same temperature when we are using them. So the temperature of the wires should be same. The third thing I'm writing is diameter of the wires. So that also affects the resistance. This should also be kept constant for all the different lengths of the wire. Okay. The next instruction is draw a table or tables with column headings to show how to display the readings. You are not required to enter any readings in the table. So first of all, we have measured the length, and we have to assign it a symbol, and let me write it small l over here. So the table would be like this. We will be measuring the length in centimeters. Then we are measuring the voltage or the potential difference in volts. Then we are measuring the current in amperes. And finally, we are calculating the resistance in ohms. The last part says explain how to use the readings to reach a conclusion. So there are two ways to answer it. The most simple one is for conclusion, we will be plotting a graph. So I'm writing plot a graph. Now, for plotting the graph, remember that the dependent variable should be on the y-axis and the independent variable should be on the x-axis. So I'm writing plot a graph of resistance, which is R, against the length of wire, which is L, to see how they are related. So the figure of or the shape of the graph is going to tell us how these two variables are related. Now, the paper has ended here. Hope you find it useful. And if you find this tutorial helpful, please like it and write down your question in the comments, and also share this video with your friends. So I'm ending the tutorial here.